just like with fractions, when I ask you to simplify your fractions or reduce your fractions, we also have to simplify or reduce square roots. And it's the same type of process where we are going to try and break the number down into smaller pieces. And before we begin to work on simplifying square roots, I would like you to fill in the chart that's on your note page with the following numbers. 1 squared, which is 1 times 1, is 1. 2 squared, 2 times 2 is 4. 3 squared, 3 times 3 is 9. 4 squared is 16. And I want you to go ahead and continue this chart, fill in this chart all the way down to 20 squared, which is 400. Now, the best thing about these videos is that you can pause them so that you can work on these before moving on. You guys can work together to try and come up with the answers on the rest of these. I'll go ahead and fill in the most difficult ones, but I'd like you to fill in 1 through 12 on your own. In that last chart, the last column of the chart that's empty, what I'd like you to do is I'd like you to show what this looks like with a square root. For example, the square root of 9 equals 3. The square root of 16 equals 4. The square root of 225 equals 15. So you're definitely going to have to pause the video here. You're going to have to do some math to fill in all of the empty boxes on this chart. All of the boxes should be filled in before you come to class tomorrow. So your first definition to put down on your notes page is that to simplify square roots is to break down the root into smaller, perfect pieces. Now, the reason I had you make this list, oops, going the wrong way. The reason I had you make this list is because these are the perfect squares. The numbers in the middle column are perfect squares. So those are the numbers we're going to look for when we're trying to simplify. So here's what I mean. For example, I could do the square root of 4 times the square root of 9, which is the square root of 36. Let's check to see if this is true. Well, what is the square root of 4? It's 2, because 2 times 2 is 4. And what is the square root of 9? 3, because 3 times 3 is 9. And I see that they're being multiplied together. So I'm wondering if that's the same as this. The square root of 36 is 6. So is this true? Yes, that is true. So what I've just learned and what you're going to write down in your notes algebraically, remember when we write things algebraically, we're using letters instead of numbers. So in your notes, what this means in algebra is that a number times another number, and you guys know I'm lazy, I don't write the little dot in the middle, they're right next to each other, so you know that they're multiplied together. If I have two numbers that are multiplied together, like 4 and 9, and I take the square root of them, I could also break them down and multiply them individually. So my example is the example I just did, that the square root of 36 is the same thing as the square root of 4 times the square root of 9. I just wrote it the other way. So because I know that I'm allowed to break down the larger number into smaller pieces, that's what I'm going to use to help me with these problems. The key, though, is going to be that I want to break them down into perfect pieces. And remember, perfect pieces, perfect numbers, are these numbers that are highlighted in yellow. 1 is perfect, 4 is perfect, 9 is perfect, 16 is perfect. If I continue down this list, 25 is perfect, 100 is perfect. So I want to be thinking about those perfect numbers when I try and do this work. Let's look at this next problem, and we'll have to use a calculator to check it to see if this is true. The square root of 4 is 2, and the square root of 10, wow, you know, I remember from my perfect quiz at the very beginning of the school year that the square root of 10 is going to be irrational. That means that it's going to look like pi. It's going to be a decimal that goes on forever and ever. It doesn't repeat. It doesn't have a pattern. So I can't do anything with that. I just have to leave it as the square root of 10. And I want to know if this is true. So I'm going to check it on a calculator. What I'm going to do first on my calculator is I'm going to do the square root of 40. And there's that crazy irrational number, 6.324. There's a bunch of 5s. 6.324. This goes on forever. It's not repeating. It's not doing any sort of pattern. And I'm going to see if what I just figured out on this other side is also true. It should match. Let's see. I'm going to begin by doing the square root of 10. So I'm going to begin by doing the square root of 10. The square root of 10 looks like this. It's an irrational number, just like I thought it would be. It's going on forever. It's not repeating. And now I'm going to do what this says up here. I'm going to times it, multiply it, by 2. And I better get the same answer. And look at that, I did. I got that same answer that I got before. 6.324. And it goes on forever with no pattern. So this worked too. It looks a little bit weird because the square root of 10 didn't get broken down anymore, but this part did. And I'd like you to add to your notes the way that we say this, the way that we say this right here, okay? On your notes, you're going to write down in quotes. The way we say this is 2 root 10, which means 2 times the square root of 10. So let's try some examples. Now here's the tricky part. The tricky part is choosing numbers that are perfect. Here's what I mean. If I asked you to break down 50, I could break it down into 5 and 10. The square root of 5 times the square root of 10. This is a true statement. But the problem is that the square root of 5 is not perfect. In fact, I'll show you right now. The square root of 5 looks like this. It's not perfect. I can't break that down. And the square root of 10, which we just saw, is also not a perfect number. So unfortunately, using 5 and 10 doesn't help me break down 50. I want to try and use something that's perfect. I know another way to make 50. What about 25 times 2? 25 times 2 is 50, and this is going to help me out because the square root of 25 is 5. What about the square root of 2? Well, the square root of 2, again, that's going to be one of those irrational numbers, so I'm just going to leave it like this. And how would I say that number? I would say 5 root 2. I guess I should spell that out. 5 root 2. Same thing with 72. I can break down 72 a lot of different ways. I know that it's even, so I'm going to try and divide by 2. And if I do that, I'm going to get 2 and 36. 2 and 36. Are either of those perfect? Well, let me go back to my list. Yep. Right there. 36 is a perfect number. The square root of 36 is 6. So this is great. When I come back to this problem, here's what I get. The square root of 36 is 6. And the square root of 2, well, there's nothing really I can do about that. So I'm just going to write the square root of 2. And I would say this is 6 root 2. Let's go ahead and prove to ourselves that what we're doing makes sense. Let's go ahead and check this last one on a calculator. I'm first going to do the square root of 72. The square root of 72 is 8.48528113. This is going on forever. No pattern, no repeating. 8.485. 8.485, and it's continuing. Now I want to check to see if this will give me that same answer. So on my calculator, I'm going to begin by doing the square root of 2. And then I'm going to multiply that by 6. And it better be the same answer. It sure is. 8.48528, continuing on forever. No pattern. It's irrational. And just like when you simplify fractions, sometimes you may have to simplify more than once. So let's say I'm working with the number 80. And I think to break down 80 using 4 and 20. 4 times 20 is 80. This is good. This is good because the square root of 4 is 2. And the square root of 20 I don't know because it's going to be one of those irrational numbers. But the problem is I'm not done reducing. I can actually break down this 20 even further. I can break down this 20 even further. And this is a part where you really have to pay attention. Stay with me. I can break down the 20 into 4 and 5. 4 times 5 is 20. And now what I'm going to have to do is a little bit tricky. The square root of 5 stays the way that it is because there's nothing I can do with that. I can't figure out what that is without a calculator. And the square root of 4 is 2. But I already had a 2 out here. I had a 2, and now I have another 2. And 2 times 2 is 4. So just like when we're reducing fractions, sometimes you may have to simplify more than once. What that means is that there was actually a better way to start. So I don't want you to erase yours. You're just going to add yours. You have a second square root of 80 on your paper. But there was actually a different way to break down 80. I can make 80 by doing this problem. 16 times 5. 5 times 6 is 30. 5 times 5 is, or 5 times 1 is 5, plus 3 is 80. So that means I could have broken this down into 16 times 5. Well, what's the square root of 16? 4. And the square root of 5 just stays as the square root of 5. I came up with the same answer, but I went there in one step because I used a bigger perfect square. 16 is a perfect square, and 4 is a perfect square. So just like sometimes when you're reducing, if you don't reduce a fraction by a big enough number, you have to keep going step after step after step. It's easier to try and find the bigger perfect piece, but sometimes we don't always find it. We just keep going then, like I did in the first example. So here's another example. This says the square root of 20 times the square root of 30. Well, the square root of 20 times the square root of 30 is going to be 600. And now I want to be able to make that better. I know that the square root of 600 is not a finished answer. Just like if you were doing a math problem and you got the answer 4/8, I'd tell you that that answer isn't wrong, but I'd tell you that that answer can be better, that you could reduce it, that you could simplify it, that you could make it better. So 4/8 isn't wrong, but it's not as good as it could be. And the square root of 600 isn't wrong, it's just not as good as it could be. So I'm going to try and break it down. I'm going to break it down, and since it's a multiple of 100, I'm going to use 100, which I know is perfect, times 6. 100 times 6 is 600, so now I have this. What's the square root of 100? Square root of 100 is 10. And the square root of 6, yeah, that's irrational. There's nothing I can do about that. So the best answer I can come up with is 10 root 6. And the final thing that you'll see has to do with simplifying fractions that have square roots. And really what this means is take the square root of the top, take the square root of the bottom. So in this first example, the square root of 3, I don't know how to do that. So I'm just going to write the square root of 3 because I can't do that without a calculator. But I do know what the square root of 4 is. The square root of 4 is 2. This is a good, complete answer. It cannot be any better. What about this next one? The square root of 2, I don't know. So I've got the square root of 2. But I do know the square root of 9. The square root of 9 is 3. That's as good as that answer can get. And on this last one, the square root of 25 is 5. And the square root of 16 is 4. That's as good as that can be. What I'd like you to notice is how the square root signs are drawn. Please notice that on this first question, the square root sign covers both numbers. It's as tall as the 3 and the 4. But then if you notice in my answer, now the square root symbol is only on the top because I already did the square root of 4. The square root of 4 was 2, so there's no square root symbol on that bottom 2 because I've already used it. I used it right here. The square root of 4 gave me 2. Same thing on this second problem. Notice that in the beginning, the square root sign is covering both numbers. It's as tall as the 2 and the 9. But in my answer, only the 2 has the square root because that's the part of this problem that I can't do. I don't know the square root of 2 without a calculator. But I can do the square root of 9. Square root of 9 is 3. That's why there's no square root symbol on that bottom 3. This concept is a very challenging concept. We will be spending a few days on it in class, so please make sure you come to class tomorrow with any questions that you might have.